Welcome to SS2 Physics. Today we explore one of the most fundamental concepts in thermodynamics, heat and its two key measurements, specific heat capacity and latent heat. Understanding how heat interacts with matter helps us explain everyday phenomena, from why it takes so long to boil a pot of water to why coastal cities have milder climates than inland areas. By the end of this lesson, you will be able to define specific heat capacity, solve numerical problems involving heat transfer, distinguish between sensible heat and latent heat, and apply the formula Q equals mc delta T with confidence. Nigeria sits within the tropics, and heat management is crucial in our daily lives, in cooking, in industries, and in understanding our climate. Let us begin. Specific heat capacity, denoted by the symbol C, is defined as the amount of heat energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius or 1 Kelvin. The SI unit of specific heat capacity is joules per kilogram per Kelvin, written as J per kg per K. The formula that governs heat transfer is Q equals m times C times delta T. Here, Q is the heat energy in joules, m is the mass in kilograms, C is the specific heat capacity, and delta T is the change in temperature. Different substances have different specific heat capacities. Water has an exceptionally high specific heat capacity of 4,200 joules per kilogram per Kelvin. This means it takes a large amount of energy to heat water compared to most other substances. Metals like copper have a much lower specific heat capacity, about 390 J per kg, which is why metal spoons heat up quickly in hot soup. Aluminium has a specific heat capacity of about 900 J per kg. This property makes water an excellent coolant in car radiators and in industrial cooling systems. It also explains why coastal areas like Lagos experience more stable temperatures than inland Saharan regions. The ocean absorbs and releases heat slowly, moderating the local climate. Let us solve a problem. A 2 kg block of iron at 20 degrees Celsius is heated to 120 degrees Celsius. The specific heat capacity of iron is 460 J per kg. How much heat energy is required? Using Q equals mc delta T, Q equals 2 times 460 times 100. Q equals 92,000 joules, or 92 kilojoules. Now let us consider latent heat. When a substance changes state, from solid to liquid, or liquid to gas, heat energy is absorbed or released without any change in temperature. This energy is called latent heat. The word latent comes from Latin meaning hidden, because the temperature stays constant even as heat flows in or out. There are two types: latent heat of fusion, which is the heat needed to change a solid to a liquid at its melting point, and latent heat of vaporization, which is the heat needed to change a liquid to a gas at its boiling point. The formula is Q equals m times L, where L is the specific latent heat in joules per kilogram. The specific latent heat of fusion of ice is 3.34 times 10 to the power 5 joules per kilogram. The specific latent heat of vaporization of water is 2.26 times 10 to the power 6 joules per kilogram. Example: calculate the heat needed to melt 0.5 kilograms of ice at 0 degrees Celsius. Q equals 0.5 times 3.34 times 10 to the power 5. Q equals 1.67 times 10 to the power 5 joules, or 167 kilojoules. Notice that this is purely for melting, no temperature change occurs. These concepts have real-world applications in Nigeria and globally. In food preservation, the high latent heat of water vapor means refrigerators remove large amounts of heat when water condenses. In cooking, knowing specific heat capacity helps engineers design efficient cookers. In medicine, the body uses latent heat through sweating. Sweat evaporates and takes heat away from the body, cooling us down. In summary, specific heat capacity C measures how much energy is needed to heat a unit mass by 1 degree. Formula Q equals mc delta T. Latent heat L measures energy needed for a change of state with no temperature change. Formula Q equals ml. Water has a very high specific heat capacity of 4,200 J per kg. Latent heat of fusion relates to solid-liquid change. Latent heat of vaporization relates to liquid-gas change. Always remember your units: joules for energy, kilograms for mass, Kelvin or degrees Celsius for temperature change. Practice these calculations regularly. They are core WAEC examination questions.